3 years ago, on Christmas morning 2021, humanity held its breath as the most ambitious telescope ever built lifted off from French Guiana into the cosmic void. 30 years in the making, $10 billion in investment, and countless sleepless nights from thousands of engineers and scientists around the world had led to this single moment. The James Webb Space Telescope was finally beginning its journey to revolutionize our understanding of the universe. If you find comfort in these gentle explorations of cosmic discovery, I'd be grateful if you'd consider subscribing and hitting that notification bell. Tonight, we're embarking on a journey through the most groundbreaking astronomical discoveries of our time. Feel free to close your eyes, breathe deep, and let your imagination soar through the depths of space as we explore what this magnificent machine has revealed about our cosmic neighborhood and beyond. Also, I'd love to know where you're listening from tonight. Comment your time and location below. There's something beautifully humbling about contemplating these cosmic revelations while scattered across our small blue planet, each of us under the same ancient sky that Webb is now helping us understand in ways we never thought possible. Let's begin. But here's what makes Webb's story truly extraordinary. This isn't just another space telescope with bigger mirrors and better cameras. This is humanity's first clear window into the cosmic dawn itself, a time machine that can peer back over 13 billion years to witness the universe when it was just an infant, still glowing with the afterglow of creation. Welcome to this journey through one of the most remarkable chapters in the history of space exploration. We'll explore how a telescope orbiting in the darkness a million miles from Earth has already rewritten textbooks, challenged fundamental theories, and opened our eyes to cosmic phenomena we never knew existed. The discoveries we're about to explore aren't just impressive scientific achievements. They're revelations that change how we see our place in the grand cosmic story. The story begins with something that might surprise you. Webb doesn't orbit our planet like its predecessor, the Hubble Space Telescope. Instead, it journeys to a special point in space called Lagrange Point 2, where the gravitational forces of Earth and the Sun create a stable parking spot a million miles away from home. Here, shielded by a tennis court-sized sunshield with the sun protection equivalent of SPF 1 million, Webb floats in perpetual darkness, its instruments cooled to temperatures colder than Pluto. This isn't just engineering for the sake of engineering. Every aspect of Webb's design serves a profound purpose. You see, the universe is expanding. As light travels across billions of years of cosmic history, it gets stretched like a rubber band being pulled apart. The visible light from the most ancient stars and galaxies has been stretched so far that it's now infrared radiation, invisible to human eyes but perfectly detectable by Webb's revolutionary instruments. This means that when Webb looks deep into space, it's literally looking back in time. The further it peers, the younger the universe becomes. It's like having a cosmic archaeology tool that can excavate layers of cosmic history, revealing secrets that have been hidden for longer than Earth itself has existed. But even the most optimistic astronomers weren't prepared for what Webb would actually find. Within just months of beginning its scientific operations in July 2022, this remarkable machine began sending back images and data that left the scientific community stunned, excited, and more than a little confused. The first shock came from the deepest reaches of space and time. In May 2024, Webb identified something that shouldn't exist according to our best understanding of cosmic evolution. A galaxy designated JD's GSZ14-0, shining brightly in the cosmic darkness just 290 million years after the Big Bang. To put this in perspective, if the entire history of the universe was compressed into a single year, this galaxy would have formed by January 8th. This discovery represents far more than just a new record holder for the most distant galaxy ever observed. It represents a fundamental challenge to everything we thought we knew about how quickly the universe could organize itself after the cosmic fireworks of creation. According to our models, galaxies this massive and luminous simply shouldn't have had enough time to form so early in cosmic history. Peter van Dokkum from Yale University, one of the scientists involved in this discovery, captured the significance perfectly when he told reporters that this is currently the most distant object known to humanity. But more importantly, he emphasized that Webb was not expected to find any galaxies this early in cosmic history, at least not at this stage of the mission. The implications are staggering. If massive mature galaxies could form this quickly after the Big Bang, it suggests that the early universe was far more active, far more efficient at building complexity than we ever imagined. It's like discovering that not only could ancient civilizations build magnificent cities, but they were doing it faster and more efficiently than modern societies with all our advanced technology. But this distant galaxy wasn't alone. Webb has discovered an entire population of surprisingly massive galaxies in the early universe, some as massive as our own Milky Way, formed within just the first 700 million years of cosmic history. These cosmic giants challenge our fundamental models of galaxy formation and force us to reconsider how quickly matter could clump together under gravity's patient influence. The mystery deepens when we examine the chemical composition of these ancient galaxies. Webb's spectroscopic capabilities allow it to analyze the light from these distant objects like a cosmic laboratory, breaking down their starlight into component wavelengths that reveal the elements present in their stars. What it found was completely unexpected. These early galaxies contain unusually high amounts of nitrogen compared to what we observe in our own sun and local stellar neighborhood. Meanwhile, most other heavy elements are present in much lower quantities than our models predict. This suggests that stellar evolution, the process by which stars forge heavy elements in their cores and scatter them through supernova explosions, was operating under very different conditions in the early universe. It's as if we discovered that ancient metallurgists were somehow producing advanced alloys using techniques we don't understand, creating compositions that our modern understanding of chemistry says shouldn't be possible. These findings suggest that our models of how stars drive the chemical evolution of galaxies are still incomplete, meaning we still don't fully understand the cosmic processes that led to the formation of planets like Earth and, ultimately, to our own existence. The plot thickens even further when we consider the shapes of these ancient galaxies. Webb has revealed that many distant galaxies have flattened, oval, disc-like, and tube-like structures rather than the familiar spiral arms or elliptical shapes we see in the local universe. This was completely unexpected and requires additional research to fully explain. It's like discovering that ancient architecture followed completely different principles than modern building techniques, creating structures that are both functional and beautiful, but operate according to rules we're only beginning to understand. These observations suggest that galaxy formation in the early universe followed pathways that our current theories struggle to explain. But Webb hasn't just found surprisingly lively early galaxies, it has also discovered extremely dead ones. These galactic corpses represent the remnants of intense star formation episodes at the cosmic dawn, galaxies that burned bright and fast before exhausting their fuel and falling into stellar hibernation. While these dead galaxies had been detected before by Hubble and ground-based telescopes, only Webb had the power to dissect their light with sufficient precision to reveal how long they've been dormant. It's like having a cosmic forensics lab that can determine not just that something died, but when and how it died, providing crucial clues about the life and death cycles of galaxies in the early universe. The team behind Webb's early galaxy observations has been clear about the revolutionary nature of these findings. As one researcher explained, up until James Webb, we never actually had observational data to help us understand the physics of the early universe. The telescope is finally allowing us to bridge the gap between the theoretical Big Bang and the remarkable collection of cosmic objects we see scattered across our night sky. These discoveries are forcing cosmologists to grapple with fundamental questions about the nature of dark matter, the efficiency of early star formation, and the basic timeline of cosmic evolution. Some researchers are beginning to wonder whether our models can be stretched and modified to accommodate these unexpected findings, or whether we need to completely reconsider our understanding of how the universe evolved from simplicity to complexity. The debate is far from settled. Some scientists propose that star formation in the early universe was extraordinarily efficient, allowing massive galaxies to assemble much more quickly than in the modern cosmos. Others suggest that we may need to revise our understanding of dark matter itself, the mysterious substance that provides the gravitational scaffolding around which galaxies form. What's certain is that Webb is providing us with observational data from an era of cosmic history that was previously accessible only through theoretical models and computer simulations. For the first time, we're seeing direct evidence of what the universe actually looked like when it was young, rather than relying on extrapolations and educated guesses based on what we observe in our local cosmic neighborhood. The implications extend far beyond academic curiosity. These discoveries are rewriting our cosmic origin story, the narrative that explains how we got from a hot, dense, relatively simple early universe to the complex, structured cosmos we inhabit today. Understanding these early epochs isn't just about satisfying human curiosity about our cosmic ancestry. It's about comprehending the fundamental processes that govern how complexity emerges from simplicity, how structure forms from chaos, and how the raw materials of stars, planets, and life itself came to be distributed throughout the cosmos. As we stand on the threshold of these remarkable revelations, we're witnessing what may be the most significant paradigm shift in cosmology since Edwin Hubble first discovered that the universe was expanding. Webb's observations of the early universe are showing us that cosmic evolution proceeded faster, more efficiently, and more dramatically than we ever dared to imagine. But these discoveries in the distant universe represent just the beginning of Webb's revolutionary impact on astronomy. The telescope's capabilities extend far beyond studying ancient galaxies to examining objects much closer to home, revealing secrets about planetary formation, stellar evolution, and the potential for life itself to emerge in cosmic environments, both familiar and utterly alien. The story of Webb's discoveries is still being written, each observation adding new chapters to our understanding of the cosmos. What we've explored tonight represents just the opening pages of what promises to be an epic tale of cosmic discovery, one that will continue to unfold as this remarkable machine peers deeper into space and further back in time than any human-made instrument before it. As Webb turned its infrared gaze from the distant cosmic dawn toward our own celestial neighborhood, it began revealing secrets hidden in plain sight. The telescope's remarkable versatility allows it to study not just the most ancient objects in the universe, but also worlds orbiting nearby stars, objects that might harbor the very conditions necessary for life to flourish. Picture this for a moment. Just 40 light-years from Earth, a small red dwarf star hosts 7 rocky planets packed so tightly together that if you stood on one world, the others would appear larger in the sky than our moon appears from Earth. This is the TRAPPIST-1 system, discovered in 2017 and immediately recognized as one of the most intriguing planetary systems ever found. What makes TRAPPIST-1 so captivating isn't just the number of Earth-sized worlds it contains, but the tantalizing possibility that some of these planets might exist in that precious zone around their star, where liquid water could survive on their surfaces. Red dwarf stars like TRAPPIST-1 are the most common type of star in our galaxy. If Earth-sized worlds orbiting red dwarfs can maintain atmospheres and potentially support liquid water, then the number of potentially habitable worlds in the Milky Way could be staggering. But there was a problem. Red dwarf stars, while long-lived and stable, have a violent youth. They tend to unleash powerful stellar flares and radiation that could strip away any atmospheres their planets might possess. For years, astronomers wondered whether the TRAPPIST-1 planets were barren, airless rocks scorched by their star's radiation, or whether some might have managed to retain the precious envelope of gas necessary to support liquid water and, potentially, life. Webb has begun to answer this question with unprecedented precision, and the results are both illuminating and surprising. Using its mid-infrared instrument, Webb made the first direct detection of thermal emission from a planet as small and cool as the rocky worlds in our own solar system. This represents a milestone that seemed almost impossible just a few years ago. The team focused their attention on TRAPPIST-1b, the innermost planet in the system. By measuring the heat energy radiating from this world in infrared wavelengths, they determined that its dayside temperature reaches about 500 Kelvin, roughly 450 degrees Fahrenheit. More importantly, these measurements suggest that TRAPPIST-1b lacks any significant atmosphere. It's a sobering reminder of how hostile space can be to the delicate conditions necessary for life as we know it. The intense radiation from the red dwarf star appears to have indeed stripped away any atmospheric gases that might have once surrounded this world, leaving behind a bare rock baking under the relentless energy of its nearby sun. But Webb's investigation didn't stop there. The telescope turned its attention to TRAPPIST-1d, a world that sits farther out in the system where conditions might be more favorable for retaining an atmosphere. This planet occupies a position where liquid water could theoretically exist on its surface, making it a prime target for studying potentially habitable conditions beyond our solar system. The results, published after careful analysis of Webb's spectroscopic data, revealed that TRAPPIST-1d also lacks an Earth-like atmosphere. As Caroline Piolet-Gorayeb from the University of Chicago explained, while we ultimately want to know if environments like Earth can exist elsewhere and under what conditions, Webb's observations allow us to rule out TRAPPIST-1d from our list of potential Earth twins or cousins. Yet even as some doors close, others open. Recent reanalysis of Webb's data on TRAPPIST-1b has revealed intriguing new possibilities. Different observational techniques and wavelengths can reveal varying aspects of these alien worlds, and fresh analysis suggests that the innermost planet might actually possess a hazy, carbon dioxide-rich atmosphere after all. Alternatively, the measurements might indicate something equally fascinating, an unexpectedly high surface temperature that could suggest the world is geologically active, perhaps roiling with volcanic activity that continuously replenishes atmospheric gases, even as stellar radiation tries to strip them away. This highlights one of the most remarkable aspects of Webb's capabilities. The telescope can study these distant worlds using multiple techniques, each revealing different pieces of the puzzle. It's like having several different microscopes, each designed to see aspects of a specimen that others cannot detect. The implications of these studies extend far beyond the TRAPPIST-1 system itself. By understanding how atmospheres survive or fail to survive around red dwarf stars, we're learning fundamental lessons about planetary habitability throughout the galaxy. These observations help astronomers refine their models of which types of worlds might be capable of supporting life and under what conditions. But Webb's exploration of alien worlds hasn't been limited to potentially habitable planets. The telescope has also turned its attention to the most massive objects in the universe, supermassive black holes that lurk at the centers of galaxies and shape the cosmic landscape through their immense gravitational influence. What Webb discovered about these cosmic monsters has been nothing short of revolutionary. In the constellation Telescopium, the telescope detected a small red compact object that existed just 500 million years after the Big Bang. This unassuming little red dot harbors what may be the earliest known black hole in the universe, a gravitational giant that challenges everything we thought we knew about how these objects form and grow. The black hole at the center of galaxy Kuiper's LRD Z9 weighs in at approximately 38 million times the mass of our Sun, making it roughly 10 times more massive than Sagittarius A star, the supermassive black hole that anchors our own Milky Way galaxy. But here's what makes this discovery truly mind-bending. This ancient black hole contains about 5% of the total mass of all the stars in its host galaxy, a ratio that far exceeds anything we observe in the modern universe. Stephen Finkelstein, one of the astronomers involved in this discovery, captured the significance perfectly when he noted that this adds to growing evidence that early black holes grew much faster than we thought possible, or they started out far more massive than our models predict. The implications are staggering. In the modern universe, supermassive black holes typically contain only about 0.1% of their host galaxy's stellar mass. Finding a black hole with such a disproportionate mass so early in cosmic history suggests that these objects were not just larger than expected, but were growing at rates that seem to defy our understanding of how matter can be consumed by gravitational fields. The mystery deepened when Webb detected the most distant black hole merger ever observed. In May 2024, the telescope identified evidence of two massive black holes in the process of combining within the galaxy system ZS7, an event occurring just 740 million years after the Big Bang. This represents not just a record for distance, but the first time such a phenomenon has been detected so early in cosmic history. Black hole mergers are among the most energetic events in the universe, releasing more energy in gravitational waves than all the stars in the observable universe emit in light. The fact that such mergers were already occurring within the first billion years after the Big Bang suggests that supermassive black holes achieve their enormous masses through rapid growth and frequent collisions, even in the universe's youth. Perhaps most intriguingly, Webb has potentially identified evidence for direct collapse black holes, massive objects that form not through the gradual growth of stellar remnants, but through the catastrophic collapse of enormous gas clouds. In the Cosmos Webb survey, astronomers discovered an unusual object nicknamed the Infinity Galaxy, displaying the distinctive shape of two compact red nuclei surrounded by rings, resembling the mathematical infinity symbol. This bizarre structure appears to have formed through the head-on collision of two disk galaxies, but what makes it truly remarkable is the supermassive black hole positioned between the two nuclei, sitting within a vast expanse of gas. The team proposes that this black hole formed through direct collapse of the gas cloud itself, a process that may explain how some of the incredibly massive black holes Webb has found in the early universe could have achieved their enormous sizes so quickly. These direct collapse scenarios represent a kind of cosmic shortcut, allowing black holes to skip the usual slow process of growth from stellar mass objects, and instead begin their existence already weighing millions of times more than our Sun. It's like finding evidence that some mountains formed not through gradual geological processes, but by having enormous chunks of rock dropped from space fully formed. But perhaps the most extreme discovery came from Webb's observation of a black hole feeding at rates that shouldn't be possible according to our understanding of physics. Using data from both Webb and the Chandra X-ray Observatory, astronomers identified a low-mass, supermassive black hole just 1.5 billion years after the Big Bang that is consuming matter at more than 40 times the theoretical limit. This phenomenon, known as super-Eddington accretion, occurs when a black hole consumes matter faster than radiation pressure should theoretically allow. It's like discovering a drain that somehow manages to empty a bathtub faster than water can flow into it, defying our understanding of the physical processes involved. Hye-won Soo from the International Gemini Observatory, who led the research team, explained that this discovery suggests a significant portion of mass growth can occur during a single episode of rapid feeding, regardless of whether the black hole originated from a light or heavy seed. These feeding frenzies, while short-lived, could help explain how supermassive black holes grew to their enormous sizes within the relatively brief time frame of the early universe. The black hole discoveries represent more than just individual objects of interest. They're revealing fundamental truths about how the universe organized itself in its earliest epochs. The relationship between supermassive black holes and their host galaxies appears to have been established very early in cosmic history, suggesting that these gravitational giants played a crucial role in shaping the structure and evolution of the cosmos itself. As Webb continues to peer deeper into space and further back in time, each discovery adds new pieces to the puzzle of cosmic evolution. The telescope is showing us that the early universe was not the simple, quiet place we once imagined, but a dynamic, rapidly evolving cosmos, where massive structures formed with surprising speed and efficiency. These revelations about black holes and distant galaxies represent just a fraction of Webb's transformative impact on astronomy. The telescope's versatility allows it to study phenomena across an enormous range of scales, from the smallest brown dwarf stars to the largest structures in the cosmos, each observation contributing to our growing understanding of how the universe works. The story takes another remarkable turn when we venture beyond the familiar boundaries of our own galaxy. For decades, astronomers have catalogued thousands of brown dwarfs, those enigmatic objects that exist in the twilight between planets and stars. Too massive to be planets, yet lacking the nuclear fires that define true stars. These cosmic misfits have been found scattered throughout the Milky Way, but always within our galactic neighborhood. Then Webb achieved something that seemed almost impossible. It detected the first rich population of brown dwarf candidates beyond our galaxy, nestled within the star cluster NGC 602. Elena Manjavakas from the Space Telescope Science Institute captured the significance of this discovery perfectly when she noted that until now, we had known of about 3,000 brown dwarfs, but they all lived inside our own galaxy. This represents more than just extending our catalogue of celestial objects. By studying these young, metal-poor brown dwarfs in an environment completely different from our local galactic neighborhood, astronomers are gaining insights into how stars and planets formed under the harsh conditions that prevailed in the early universe. It's like discovering artifacts from an ancient civilization in a previously unexplored continent. Artifacts that reveal how people lived and worked under conditions completely unlike anything in the modern world. But Webb didn't stop at finding brown dwarfs in distant galaxies. It pushed the boundaries of what we thought possible in star formation itself. The telescope identified the new record holder for the smallest free-floating brown dwarf ever discovered. An object with only 3 to 4 times the mass of Jupiter, drifting alone through space without a parent star. Kevin Luhman from Pennsylvania State University, who led this research, explained that one of the most basic questions in astronomy textbooks is simply, what are the smallest stars? Webb is helping us answer that fundamental question by identifying objects that challenge our understanding of the minimum mass required for stellar formation. This tiny brown dwarf, along with two other ultra-low mass objects discovered in the same survey, represents the extreme lower limit of what can form through stellar-like processes. These objects are so small and cool that they blur the line between failed stars and massive planets, forcing astronomers to reconsider the fundamental mechanisms that govern how matter collapses under gravity to form distinct types of cosmic objects. The discovery becomes even more intriguing when we consider that Webb has also found brown dwarfs surrounded by protoplanetary disks, the swirling disks of dust and gas from which planets are born. In the Orion Nebula, the telescope confirmed 20 brown dwarfs with these planet-forming disks, demonstrating that even these failed stars can retain the raw materials necessary for planetary formation. This revelation challenges previous models that suggested brown dwarfs would be too small and cool to maintain the conditions necessary for planet formation. Instead, Webb is showing us that the processes that lead to planetary systems might be far more widespread and diverse than we ever imagined. It's like discovering that not only can small businesses succeed in challenging economic environments, but they can also spawn entire ecosystems of related enterprises. The implications ripple through our understanding of how common planetary systems might be throughout the galaxy. If even brown dwarfs can form planets, then the number of worlds in our cosmic neighborhood could be far larger than our most optimistic estimates. Webb's versatility extends even closer to home, studying objects within our own solar system with unprecedented detail. When astronomers discovered asteroid 2024 YR4 in December 2024, they faced a critical challenge. This space rock has a very small but non-zero chance of impacting Earth in 2032, but determining the actual hazard it poses requires knowing its precise size. The problem is that visible light observations can only tell us how bright the asteroid appears, not how large it actually is. A small, highly reflective asteroid can appear just as bright as a large, dark one. Current estimates place 2024 YR4 somewhere between 40 and 90 meters across, a range that makes all the difference when assessing potential impact hazards. Webb's infrared capabilities offer a solution. Instead of relying on reflected visible light, the telescope can measure the heat that the asteroid emits directly. This thermal emission provides a much more accurate assessment of the object's actual size, helping scientists determine whether we're dealing with a 40-meter rock that would likely burn up in Earth's atmosphere, or a 90-meter boulder that could cause significant damage if it reached the surface. This demonstrates how Webb's revolutionary technology serves not just our cosmic curiosity, but also our practical needs as inhabitants of a planet that orbits through a solar system filled with potentially hazardous objects. The telescope represents our most advanced early warning system for threats that could emerge from the depths of space. But Webb's solar system observations extend far beyond potentially dangerous asteroids. The telescope has studied interstellar visitors like Comet 3I Atlas, objects that originate outside our solar system and provide unique insights into the composition and conditions of other stellar neighborhoods. These interstellar wanderers offer a rare opportunity to sample material that formed around distant stars, carrying with them chemical signatures that reveal the processes at work in alien solar systems. Because these objects are just passing through, astronomers must use every available tool to study them before they disappear back into the cosmic darkness forever. Webb's observations of interstellar comets represent a form of cosmic archaeology, allowing us to analyze samples from distant regions of the galaxy without the need for interstellar travel, It's like having visitors from foreign countries arrive at your doorstep, carrying artifacts that reveal the culture and conditions of their homeland. The telescope has also turned its attention to some of the most beautiful and complex structures in our local cosmic neighborhood. When Webb observed the intricate patterns of interstellar dust and gas, it revealed details resembling the knots and whirls of wood grain, structures so fine and complex that they left astronomers genuinely shocked. Jacob Jenkson from Caltech, principal investigator of one such study, captured the team's amazement when he noted that they were pretty shocked to see this level of detail. The observations revealed layers like an onion, structures that astronomers believe exist throughout the galaxy, but had never been able to see inside before. These observations are allowing scientists to map the true three-dimensional structure of the interstellar medium for the first time, revealing how matter flows and organizes itself in the spaces between stars. It's like having a detailed topographical map of an ocean floor that was previously hidden beneath murky waters. Closer to home, Webb has provided extraordinary new views of familiar objects in our own solar system. The telescope's observations of Jupiter revealed previously unseen features above the planet's iconic Great Red Spot, a region that was previously thought to be relatively unremarkable, but actually hosts a variety of intricate structures and activity. Webb's infrared vision has captured new details of auroras dancing in Jupiter's atmosphere, phenomena that result from the interaction between the planet's powerful magnetic field and charged particles streaming from the Sun. These observations demonstrate how Webb can study planetary atmospheres within our own solar system with unprecedented detail and precision. The telescope has also provided crucial insights into Saturn's moon Titan, that enigmatic world shrouded in a thick, hazy atmosphere of nitrogen and methane. By combining Webb's data with observations from ground-based telescopes, scientists have observed evidence of cloud convection in Titan's northern hemisphere for the first time. Most of Titan's lakes and seas are located in this northern region, and they are likely replenished by occasional rains of methane and ethane. Webb has detected key carbon-containing molecules that provide insight into the chemical processes operating in Titan's complex atmosphere, revealing details about the methane cycle that operates on this distant moon, much like the water cycle on Earth, but at temperatures hundreds of degrees colder. These observations of Titan represent more than just planetary science. They provide insights into the kinds of chemical processes that might operate on worlds throughout the galaxy, worlds where conditions are too extreme for liquid water, but where other substances might create the complex chemistry necessary for life as we don't yet know it. Throughout all of these discoveries, from the most distant galaxies to objects in our own solar system, Webb is demonstrating something profound about the nature of scientific exploration itself. Each observation builds upon previous knowledge while simultaneously opening new questions that we hadn't even known to ask. The telescope is revealing that the universe operates on principles of complexity and interconnection that extend across all scales of space and time. The same physical laws that govern the formation of the earliest galaxies also determine how dust organizes itself in nearby nebulae. The same processes that create heavy elements in stellar cores also influence the composition of asteroids in our own solar system. Webb is showing us that astronomy is not just about cataloging distant objects, but about understanding the fundamental processes that connect everything from the smallest particles to the largest structures in the cosmos. Each discovery adds another thread to the vast tapestry of cosmic understanding, revealing patterns and relationships that speak to the underlying unity of physical law throughout the universe. As we continue this journey through Webb's discoveries, we find ourselves confronting not just new facts about the cosmos, but new ways of thinking about our place within it. The telescope is revealing a universe that is simultaneously more strange and more comprehensible than we ever imagined. A cosmos where the familiar and the alien coexist in patterns of breathtaking beauty and complexity. The story of Webb's discoveries is far from over. Each day brings new observations, new data, new insights that challenge our assumptions and expand our understanding. What we've explored represents just the beginning of what promises to be a revolution in cosmic knowledge, one that will continue to unfold as this remarkable machine peers deeper into the mysteries of space and time than any human instrument before it. As Webb's revolutionary gaze swept across the cosmos, it began to unveil secrets that exist in the shadowy realm between the familiar and the utterly alien. In distant star-forming regions, where cosmic nurseries birth new suns from clouds of gas and dust, the telescope discovered phenomena that challenge our most basic assumptions about how stellar systems come to be. Picture vast stellar nurseries where baby stars are taking their first breaths, surrounded by swirling disks of material that will eventually coalesce into planets, moons, and the building blocks of complexity itself. Webb has peered into these cosmic cradles with unprecedented clarity, revealing structures so intricate and beautiful that they seem almost too perfect to be real. In one particularly striking observation, the telescope examined a stellar nursery where jets of superheated gas shoot outward from newly formed stars at velocities that stagger the imagination. These stellar jets, invisible to our eyes but blazing bright in Webb's infrared vision, carve through surrounding clouds like cosmic lightsabers, sculpting the very environment from which future planetary systems will emerge. What makes these observations truly remarkable is not just their beauty, but what they reveal about the violent yet creative processes that govern star formation. Each jet represents a young star learning to regulate its own growth, ejecting excess material that would otherwise cause it to collapse under its own weight. It's a delicate cosmic balancing act, one that determines whether a star will live a long, stable life, capable of nurturing planetary companions, or burn out quickly in a brief but spectacular display. But Webb's most haunting discoveries come from regions where stars have already lived out their entire cosmic stories. When massive stars exhaust their nuclear fuel, they don't simply fade away quietly. Instead, they explode in cataclysmic events called supernovas, scattering the heavy elements forged in their cores across vast regions of space. Webb has observed the aftermath of these stellar deaths with exquisite detail, revealing expanding shells of glowing gas, enriched with the very elements that make planets and life possible. Carbon, oxygen, silicon, iron, all the materials that form the foundation of terrestrial worlds and biological complexity, are distributed through these spectacular stellar obituaries. In one particularly moving observation, Webb captured the remnant of a supernova that exploded centuries ago, its expanding shell of debris still glowing with the heat of its violent birth. Within this cosmic graveyard, new stars are already beginning to form, fed by the enriched material scattered by their stellar ancestor. It's a profound reminder of the cyclical nature of cosmic evolution, where death and birth are intimately connected in an endless dance of renewal. The telescope has also revealed something unexpected about how these stellar explosions shape their surrounding environments. Rather than simply blasting material outward in all directions, supernovas create complex, three-dimensional structures that channel and direct the flow of enriched gas. These structures act like cosmic highways, guiding heavy elements toward regions where they can be incorporated into the next generation of stars and planets. This discovery has profound implications for understanding how planets like Earth acquired the diverse chemical elements necessary for geological complexity and biological evolution. The distribution of heavy elements throughout the galaxy is not random, but follows patterns established by the intricate geometry of ancient stellar explosions. Webb's observations extend beyond individual stars to encompass entire stellar populations. In globular clusters, ancient collections of stars that formed when the universe was young, the telescope has revealed details about stellar evolution that were previously hidden. These stellar cities contain some of the oldest stars in the galaxy, cosmic time capsules that preserve information about conditions in the early universe. By studying the light from these ancient stars, astronomers can reconstruct the chemical history of our galaxy, tracing how successive generations of stellar death and birth have gradually enriched the cosmic environment with the elements necessary for planetary formation and biological complexity. But perhaps Webb's most philosophically significant discoveries involve the detection of organic molecules in space. In the cold, dark regions between stars, where temperatures hover just above absolute zero, the telescope has identified complex carbon-based compounds that serve as the building blocks of biological chemistry. These molecules, floating in the vast emptiness between stellar systems, suggest that the chemical precursors of life are not rare cosmic accidents, but common features of the galactic environment. Ice-covered dust grains in interstellar space serve as cosmic chemistry laboratories, where simple molecules combine over millions of years to create increasingly complex organic compounds. When new stars form and their radiation heats these frigid regions, these organic molecules are released into the surrounding space, where they can be incorporated into forming planetary systems. This means that planets may begin their existence already seeded with the chemical ingredients necessary for biological evolution. Webb has traced these organic molecules from their formation in interstellar space to their incorporation into the atmospheres of distant exoplanets. The telescope can detect the spectroscopic signatures of these compounds in the atmospheres of alien worlds, providing our first direct evidence of complex chemistry operating on planets orbiting other stars. In one particularly intriguing observation, Webb detected water vapor, carbon dioxide, and complex organic molecules in the atmosphere of an exoplanet orbiting a star similar to our own Sun. While this world is too hot to support life as we know it, the detection of these compounds demonstrates that the chemical ingredients for biology can survive the violent processes of planetary formation and remain available for potential biological evolution. These atmospheric studies represent a new frontier in the search for life beyond Earth. By analyzing the chemical composition of exoplanet atmospheres, astronomers can begin to identify worlds where the conditions might be suitable for biological processes to take hold and flourish. But Webb's atmospheric studies have also revealed how fragile these conditions can be. The telescope has observed exoplanets where stellar radiation has stripped away most of their atmospheric gases, leaving behind barren worlds that might once have possessed the ingredients for habitability. These observations serve as sobering reminders of how delicate the balance must be for worlds to maintain the conditions necessary for life over geological timescales. The telescope has also made groundbreaking observations of rogue planets, worlds that have been ejected from their original stellar systems and now wander alone through the cosmic darkness. These orphaned worlds, invisible to conventional telescopes because they emit no light of their own, glow faintly in the infrared radiation that Webb can detect. The discovery of these wandering worlds suggests that planetary formation is an even more chaotic process than previously imagined. Gravitational interactions during the early stages of stellar system formation can fling planets into interstellar space, where they spend eternity drifting through the void between stars. Some of these rogue planets might retain enough internal heat to maintain subsurface oceans beneath frozen surfaces, creating potential habitats for life that exist completely independent of any star. These dark worlds challenge our star-centric view of habitability and suggest that life might find ways to survive in environments we had never considered. Webb's observations of stellar nurseries have also revealed the incredible diversity of planetary system architectures. Rather than the orderly arrangement we see in our own solar system, with small rocky planets close to the Sun and large gas giants farther out, many stellar systems display configurations that seem almost random. The telescope has observed systems where massive planets orbit extremely close to their parent stars, completing full orbits in just a few days. Other systems contain multiple planets locked in complex gravitational resonances, their orbits synchronized like the movements of a cosmic clockwork mechanism. These diverse architectures suggest that planetary formation is influenced by countless variables, from the initial composition of the stellar nursery to the timing of various formation processes, to random gravitational encounters that can reshape entire systems. Each planetary system tells its own unique story of cosmic evolution. In studying these varied planetary arrangements, Webb is helping astronomers understand why our own solar system has the particular configuration it does. The orderly spacing of our planets, with terrestrial worlds in the inner system and gas giants in the outer regions, appears to be just one possible outcome among many different evolutionary pathways. The telescope has also made remarkable discoveries about the moons of gas giant planets in our own solar system. Webb's observations of Jupiter's moons have revealed active geological processes that were previously undetected. Volcanic activity on Io, the most volcanically active body in the solar system, appears to be even more dynamic than previously realized. On Europa, Jupiter's ice-covered moon, Webb has detected plumes of water vapor erupting from the surface, providing direct evidence of the subsurface ocean that lies beneath the frozen shell. These plumes offer a potential pathway for studying the chemistry of Europa's hidden sea without the need to drill through kilometers of ice. Similar observations of Saturn's moon Enceladus have revealed that its subsurface ocean contains complex organic molecules, suggesting that this distant world possesses the chemical ingredients necessary for biological processes. The detection of these compounds in the plumes that Enceladus ejects into space provides tantalizing hints that life might exist in environments completely unlike anything on Earth. These discoveries about icy moons throughout our solar system have profound implications for the search for life beyond Earth. Rather than focusing solely on planets that orbit within the habitable zones of their stars, astronomers are beginning to realize that moons with subsurface oceans might be among the most promising places to search for biological activity. Webb's studies of these icy worlds are revealing that liquid water, one of the key requirements for life as we know it, might be far more common throughout the galaxy than previously imagined. Tidal heating from massive parent planets can maintain liquid oceans beneath ice shells for billions of years, creating stable environments where biological evolution could potentially occur. The telescope has also made unexpected discoveries about the composition of comets, those ancient wanderers that preserve samples of the original materials from which our solar system formed. Webb's spectroscopic analysis of comet atmospheres has revealed complex organic molecules that formed in the frigid outer regions of the early solar system. These comets serve as cosmic time capsules, carrying pristine samples of the materials that existed during the earliest phases of planetary formation. By studying their composition, astronomers can reconstruct the chemical environment in which Earth and the other terrestrial planets formed billions of years ago. The organic compounds detected in comets include some of the same molecules that are essential for biological processes on Earth. This supports the hypothesis that comets may have delivered some of the chemical ingredients necessary for life during the late heavy bombardment period, when these ancient objects frequently collided with the inner planets. Webb's observations are revealing that the boundary between astronomy and biology is far more fluid than we once imagined. The telescope is showing us that the chemical processes that lead to biological complexity operate throughout the cosmos, from the cold depths of interstellar space to the warm surfaces of potentially habitable exoplanets. As we trace these connections between stellar evolution, planetary formation, and the emergence of biological complexity, we begin to see our own existence not as an isolated cosmic accident, but as part of a vast network of physical and chemical processes that operate throughout the universe. Each observation adds another piece to this cosmic puzzle, revealing new connections and relationships that help us understand our place in the grand scheme of cosmic evolution. Webb is showing us that we are not separate from the universe we study, but intimately connected to its deepest processes and most fundamental patterns. The telescope continues to push the boundaries of what we thought possible in astronomical observation, revealing phenomena that challenge our theories and expand our imagination. Each new discovery opens doors to questions we hadn't even known to ask, ensuring that the journey of cosmic discovery will continue for generations to come. As Webb peers deeper into space and further back in time, it carries with it our hopes and dreams, our curiosity and wonder, our deep human need to understand our place in the vast cosmic story. The discoveries we've explored tonight represent just the beginning of what promises to be the most remarkable period of astronomical discovery in human history. The revelations continue to cascade from Webb's observations, each more extraordinary than the last. As the telescope turned its attention to some of the most enigmatic objects in the cosmos, it began to uncover secrets about cosmic phenomena that exist at the very edges of our understanding. In the heart of active galaxies, where supermassive black holes devour matter with an appetite that defies comprehension, Webb has observed jets of material streaming outward at velocities approaching the speed of light. These cosmic fountains, stretching across distances that dwarf entire star systems, represent some of the most powerful forces in the universe. What makes these observations truly remarkable is not just the scale of these phenomena, but the precision with which Webb can study them. The telescope can trace individual knots of material as they race along these jets, revealing how energy and matter behave under conditions so extreme that they exist nowhere else in the natural world. These jets serve as cosmic laboratories, where the fundamental laws of physics are pushed to their absolute limits. The material within them experiences gravitational fields billions of times stronger than anything we encounter on Earth, temperatures that exceed those found in stellar cores, and magnetic fields so intense they could influence matter from distances measured in light years. By studying these extreme environments, astronomers are testing our understanding of relativity, quantum mechanics, and plasma physics in regimes that no earthbound laboratory could ever hope to replicate. Each observation provides new insights into how matter and energy behave when subjected to forces that stretch the very fabric of space-time itself. But Webb's most haunting discoveries come from regions where galaxies themselves are dying. In cosmic graveyards scattered throughout the universe, the telescope has observed the final moments of galactic evolution, where stellar formation has ceased and entire stellar populations are fading into darkness. These galactic fossils tell stories of cosmic violence and renewal that span billions of years. Some died quietly, exhausting their reserves of star-forming gas over countless eons until no new suns could ignite. Others met more violent ends, torn apart by gravitational encounters with neighboring galaxies, or consumed by the ravenous appetite of central black holes. In one particularly poignant observation, Webb captured a galaxy in the process of being slowly dismembered by its larger neighbor. Streams of stars, gas, and dust stretch between the two systems like cosmic bridges, carrying the smaller galaxy's substance into the gravitational embrace of its massive companion. This celestial cannibalism represents one of the fundamental processes that have shaped cosmic evolution since the earliest epochs. Larger galaxies grow by consuming their smaller neighbors, a process that continues today throughout the universe. Webb's observations allow us to witness this cosmic recycling in exquisite detail, seeing how matter flows from one cosmic structure to another across scales that boggle the imagination. The telescope has also revealed the unexpected beauty hidden within cosmic destruction. When galaxies collide and merge, the gravitational chaos triggers spectacular bursts of star formation. Webb has observed these stellar baby booms in unprecedented detail, seeing how the violent mixing of galactic materials creates conditions perfect for nurturing new generations of suns. In these collision zones, stars form at rates hundreds of times faster than in quiescent galaxies like our own Milky Way. The night sky of a planet in such a system would blaze with the light of countless newborn stars, creating celestial displays of unimaginable beauty and intensity. These starburst galaxies burn bright but briefly in cosmic terms. Their furious pace of stellar formation exhausts available raw materials within just a few million years, leaving behind populations of massive stars that will themselves explode as supernovas in relatively short order. Its cosmic evolution accelerated to breakneck speeds. Webb's infrared vision allows it to peer through the dust clouds that shroud these stellar nurseries, revealing the intricate structures within. The telescope has observed spiral patterns, shockwaves, and turbulent flows that sculpt the distribution of star-forming material with artistic precision. These observations reveal that even in the most chaotic cosmic environments, physical processes create patterns of startling regularity and beauty. Gravity, magnetism, and fluid dynamics work together to organize matter into structures that follow mathematical relationships as elegant as any human artwork. The telescope has also made groundbreaking discoveries about the role of magnetic fields in cosmic evolution. These invisible forces, which extend across vast regions of space, help channel the flow of matter and energy throughout the universe. Webb can detect the subtle effects of these fields by observing how they influence the polarization of light from distant objects. In star-forming regions, magnetic fields act like cosmic shepherds, guiding the collapse of gas clouds and determining where and how new stars will be born. In the spaces between galaxies, these same fields help organize the flow of matter along the cosmic web, the vast network of dark matter filaments that connects all large-scale structures in the universe. The discovery that magnetic fields play such a crucial role in cosmic organization has profound implications for our understanding of how the universe evolved from the relatively smooth conditions that existed shortly after the Big Bang to the complex, structured cosmos we observe today. Webb has also revealed unexpected connections between the largest and smallest scales in the universe. The telescope's observations show that the same physical processes that govern the behavior of individual atoms also determine how entire galaxy clusters evolve over billions of years. Quantum mechanical effects that operate on subatomic scales influence the behavior of matter in the extremely low-density environments found between galaxies. Meanwhile, gravitational processes that shape the largest cosmic structures also determine how matter flows within individual stellar systems. These connections suggest that the universe operates as a unified system, where phenomena occurring on vastly different scales are intimately linked through the fundamental laws of physics. Webb is revealing a cosmos that is simultaneously more complex and more comprehensible than we ever imagined. The telescope has made particularly intriguing discoveries about dark matter, that mysterious substance that outweighs ordinary matter by a factor of 5 throughout the universe. While dark matter doesn't emit or absorb light, Webb can detect its presence through its gravitational effects on visible matter. In galaxy clusters, the most massive structures in the universe, Webb has observed how dark matter sculpts the distribution of ordinary matter into intricate patterns. These observations provide crucial tests of our theories about dark matter's properties and behavior. The telescope has detected subtle distortions in the shapes of distant galaxies caused by the gravitational lensing effects of intervening dark matter concentrations. These cosmic mirages allow astronomers to map the distribution of dark matter throughout the universe with unprecedented precision. These dark matter maps reveal a cosmos dominated by vast networks of invisible scaffolding, within which ordinary matter organizes itself into the stars and galaxies we can observe. It's like discovering that a familiar landscape is actually supported by an elaborate but invisible architecture that determines every visible feature. Webb's observations are also shedding light on the nature of dark energy, the mysterious force that drives the accelerating expansion of the universe. By studying how cosmic structures have evolved over billions of years, the telescope provides crucial data for understanding this enigmatic component of the cosmos. The expansion of space itself affects how light travels from distant objects to our telescopes. Webb can measure these effects with extraordinary precision, providing new insights into how dark energy has influenced cosmic evolution throughout the universe's history. These measurements suggest that dark energy's influence has not been constant throughout cosmic time. Instead, its effects appear to have changed as the universe has aged, with implications that could revolutionize our understanding of the cosmos's ultimate fate. As Webb continues its observations, it's becoming clear that we're witnessing not just individual discoveries, but a fundamental shift in how we understand the universe itself. The telescope is revealing a cosmos that operates according to principles of connection and relationship that extend across all scales of space and time. Each observation builds upon previous knowledge, while simultaneously opening new avenues of investigation. The telescope is showing us that the universe is not a collection of isolated objects, but a unified system where everything influences everything else through networks of physical relationship that span the entire observable cosmos. The discoveries we have explored represent more than scientific achievements. They're revelations about the nature of existence itself, about how complexity emerges from simplicity, how order arises from chaos, and how the fundamental forces of nature conspire to create a universe capable of contemplating its own existence. Webb is teaching us that we are not merely observers of cosmic phenomena, but participants in the very processes we study. The atoms in our bodies were forged in stellar cores. The energy that powers our thoughts flows from nuclear reactions in our sun, and the gravitational fields that keep us anchored to Earth extend throughout the cosmos, connecting us to the most distant galaxies. As the telescope continues its revolutionary survey of the cosmos, each new observation adds another thread to the vast tapestry of cosmic understanding. We're witnessing the birth of a new astronomy, one that reveals connections and relationships between phenomena that were previously thought to be completely separate. The story of Webb's discoveries is far from complete. The telescope has only just begun to explore the cosmic landscape, and each day brings new observations that challenge our assumptions and expand our understanding. What we've explored tonight represents just a fraction of the revolutionary insights that this remarkable machine will provide over its operational lifetime. The journey continues, carrying us deeper into the mysteries of space and time, revealing truths about the universe that will transform how we see ourselves and our place in the grand cosmic story. Webb is not just showing us what the universe looks like, it's showing us what the universe means, and how every aspect of cosmic evolution has contributed to the remarkable emergence of consciousness capable of contemplating its own origins. In the quiet darkness of space, a million miles from Earth, this extraordinary machine continues its patient work, gathering photons that have traveled across billions of years of cosmic history. Each particle of light carries with it information about phenomena so distant in space and time that they existed before our sun was born, before our galaxy took its current shape, before the conditions necessary for life had even begun to emerge. Yet somehow, through the remarkable convergence of human ingenuity and cosmic circumstance, we find ourselves capable of capturing and interpreting these ancient messengers. Webb represents the culmination of countless human dreams and aspirations, a testament to our species' irrepressible desire to understand the universe that gave birth to us. The telescope continues its observations, each one adding new chapters to the greatest story ever told. The story of how the universe evolved from simplicity to complexity, from darkness to light, from silence to the emergence of minds capable of wonder. And in that ongoing story, we find not just scientific knowledge, but something deeper and more profound, an understanding of our place in the vast, interconnected web of cosmic existence. The revelations streaming from Webb's instruments have begun to paint a picture of cosmic evolution that is simultaneously more violent and more beautiful than we ever dared imagine. As the telescope peers into the most distant reaches of space and time, it's uncovering evidence of processes that operated when the universe was barely recognizable compared to the cosmos we inhabit today. In those primordial epochs, when the universe was still finding its rhythm after the chaos of creation, Webb has detected something that challenges our most fundamental assumptions about how cosmic structures form and evolve. The telescope has observed what appears to be fully mature stellar systems existing at times when our models suggest they should still be in their infancy. These ancient stellar populations display chemical signatures that seem almost impossible given the brief time available for their formation. The heavy elements detected in their spectra should have required multiple generations of stellar death and rebirth to accumulate. Yet here they are, shining in the cosmic dawn when the universe was still learning how to make stars at all. It's like discovering a master craftsman's workshop in a newly founded settlement, complete with tools and techniques that should have taken centuries to develop. The implications ripple through our understanding of stellar evolution, forcing astronomers to reconsider whether the early universe operated according to rules we haven't yet learned to recognize. But perhaps even more intriguing are Webb's observations of cosmic voids, those vast empty regions that exist between the great filaments of the cosmic web. For decades, these spaces were thought to be nearly empty, cosmic deserts, where little of interest occurs. Webb has revealed that these supposedly barren regions harbor their own subtle but profound mysteries. Within these cosmic emptiness, the telescope has detected faint streams of matter flowing along invisible gravitational currents, like rivers running through a landscape we cannot see. These flows suggest that even the most apparently vacant regions of space are actually threaded with complex networks of dark matter filaments, creating pathways along which ordinary matter can travel across cosmic distances. The discovery transforms our understanding of how matter moves throughout the universe. Rather than simply falling toward massive structures under gravitational attraction, material appears to follow elaborate highway systems that span hundreds of millions of light years. These cosmic transit routes help explain how galaxies can maintain steady supplies of fresh material for star formation over billions of years. Webb has also made disturbing discoveries about the fate of matter that falls into these cosmic transportation networks. The telescope has observed streams of gas that appear to be heating up as they flow along these invisible channels, glowing with thermal radiation that suggests they're being compressed and accelerated by forces we're only beginning to understand. This heating process has profound implications for galactic evolution. As fresh material flows towards star-forming regions, it may become too hot to easily condense into new stars, potentially limiting the rate at which galaxies can grow and evolve. The cosmic web isn't just a passive framework for organizing matter. It's an active participant in determining how efficiently the universe can create complexity. The telescope's observations extend beyond individual cosmic structures to encompass the universe's overall architecture. Webb has begun to map the three-dimensional distribution of matter throughout space with unprecedented precision, revealing patterns that extend across the entire observable cosmos. These cosmic surveys show that the universe's large-scale structure resembles a vast biological organism, with dense nodes connected by filamentary networks that pulse with flows of matter and energy. The resemblance to neural networks or circulatory systems is so striking that some astronomers have begun to wonder whether the universe itself might possess forms of organization that we're only beginning to recognize. The implications are both humbling and inspiring. If the cosmos operates according to principles of organization that mirror biological systems, it suggests that the emergence of life and intelligence might not be cosmic accidents, but natural consequences of the universe's tendency to create increasingly complex forms of order. Webb has also made groundbreaking discoveries about how information flows throughout the cosmic web. The telescope can detect subtle correlations in the properties of galaxies separated by vast distances, correlations that suggest these systems are somehow connected through processes that operate faster than light can travel between them. These quantum-like correlations on cosmic scales challenge our understanding of causality and locality. If widely separated regions of the universe can maintain coordinated behavior, it implies the existence of communication mechanisms that transcend the speed of light limitation that governs most physical processes. The phenomenon may be related to quantum entanglement, where particles that have interacted in the past maintain mysterious connections regardless of the distance that separates them. If similar processes operate on cosmic scales, it would mean that the universe possesses forms of unity that extend far beyond anything we've previously imagined. As Webb continues to probe these cosmic mysteries, each observation raises new questions about the fundamental nature of reality itself. The telescope is revealing a universe that operates according to principles of connection and relationship that we're only beginning to comprehend. The discoveries extend to our understanding of time itself. Webb's observations of the most distant objects reveal that cosmic evolution hasn't proceeded at the steady, predictable pace that our theories suggest. Instead, the early universe appears to have experienced periods of accelerated development punctuated by intervals of relative stability. These temporal irregularities suggest that cosmic history has been shaped by events and processes that operated on timescales we haven't properly accounted for in our models. The universe may have experienced growth spurts and quiet periods, much like a living organism, rather than evolving at the constant rate assumed by most cosmological theories. The telescope has detected evidence of ancient cosmic catastrophes that temporarily disrupted the normal course of galactic evolution. These events, possibly related to the merger of supermassive black holes or the collision of dark matter structures, appear to have triggered periods of intense activity, followed by long intervals of recovery. Understanding these temporal patterns has profound implications for predicting the universe's future evolution. If cosmic development proceeds in fits and starts rather than at a steady pace, it means that our current epoch may be either a period of relative calm before another burst of activity, or the beginning of a long decline toward cosmic senescence. Webb's most philosophically challenging discoveries involve observations that seem to suggest the universe possesses forms of memory. The telescope has detected correlations between the properties of cosmic structures and events that occurred billions of years in their past, as if the cosmos somehow retains information about its own history. These cosmic memories appear to be encoded in the subtle patterns of matter distribution, the orientations of galactic rotation, and the chemical compositions of stellar populations. It's as if the universe has developed its own form of information storage, preserving records of ancient events in the very fabric of space-time itself. The implications are staggering. If the cosmos can remember its own past, it suggests that consciousness and information processing might be fundamental features of reality rather than rare accidents that emerged only with biological evolution. We might be living within a universe that is, in some sense, aware of itself. Webb has also made discoveries that challenge our understanding of the relationship between consciousness and cosmos. The telescope has observed structures that appear to process information in ways that mirror neural networks, creating patterns of activity that flow through cosmic filaments like thoughts moving through a vast mind. These observations don't prove that the universe is conscious in any conventional sense, but they do suggest that the boundary between mind and matter might be far more fluid than we've traditionally assumed. The same physical processes that give rise to consciousness in biological systems appear to operate throughout the cosmos on scales that dwarf individual planets and solar systems. As we contemplate these revelations, we find ourselves confronting questions that extend far beyond astronomy into the deepest mysteries of existence itself. Webb isn't just showing us what the universe contains. It's revealing what the universe might actually be, what role consciousness plays in cosmic evolution, and how our own awareness connects to the vast networks of information processing that appear to operate throughout space and time. The telescope continues its observations, each one adding new layers to our understanding of cosmic complexity. We're witnessing not just the discovery of new phenomena, but the birth of entirely new ways of thinking about reality, consciousness, and our place in the grand scheme of existence. These insights transform how we see ourselves and our relationship to the cosmos. Rather than being isolated observers studying a foreign universe, we're beginning to understand that we might be integral components of a vast cosmic information processing system, temporary arrangements of matter and energy that have achieved the remarkable ability to contemplate their own cosmic context. Webb's discoveries suggest that the universe has been preparing for the emergence of consciousness since its earliest moments, creating the conditions necessary for matter to organize itself into forms capable of self-awareness and cosmic contemplation. We are not accidents in an indifferent cosmos, but perhaps inevitable consequences of the universe's tendency to create increasingly sophisticated forms of organization and complexity. The telescope's observations continue to reveal new connections between seemingly unrelated phenomena, showing us that every aspect of cosmic evolution contributes to the grand narrative of increasing complexity and awareness. From the formation of the first atoms to the emergence of conscious beings capable of building instruments like Webb itself, the universe appears to be engaged in an ongoing project of self-discovery. As Webb peers deeper into space and further back in time, it carries with it not just our scientific curiosity, but our deepest questions about meaning, purpose, and connection. The telescope represents humanity's most ambitious attempt to understand not just what we are, but why we are, and how our existence relates to the vast cosmic story that began with the Big Bang and continues to unfold around us every day. The journey of discovery continues, each observation adding new chapters to the most important story ever told, the story of how the universe gave birth to minds capable of understanding their own cosmic origins. And in that ongoing tale, we find not just scientific knowledge, but something far more precious, a sense of belonging to something magnificent, mysterious, and ultimately meaningful that extends across all of space and time. Tonight, as you settle into sleep, you can rest knowing that Webb continues its patient work in the cosmic darkness, gathering ancient light that carries within it the secrets of our deepest origins. The telescope serves as our ambassador to the universe, our mechanical extension reaching across impossible distances to touch the very foundations of existence itself. Each photon it captures has traveled across billions of years to reach us, carrying information about places and times so remote that they existed before our solar system was even a whisper in a cloud of interstellar gas. Yet through Webb's remarkable capabilities, we can decipher these ancient messages and reconstruct the story of how everything we know and love came to be. The discoveries we've explored tonight represent just the beginning of Webb's revolutionary impact on human understanding. As this extraordinary machine continues its observations over the years to come, it will undoubtedly reveal phenomena we haven't even imagined yet, answering questions we didn't know to ask, and opening mysteries we never suspected existed. But perhaps Webb's greatest gift is not the specific discoveries it makes, but the sense of wonder and connection it fosters. Through its observations, we come to understand that we are not separate from the cosmic story we study, but integral participants in the universe's ongoing journey of self-discovery and evolution. In the gentle darkness that surrounds you now, remember that you are made of elements forged in the hearts of ancient stars, arranged in patterns complex enough to contemplate their own cosmic heritage. You are the universe becoming aware of itself, a temporary flowering of consciousness in the vast garden of existence. The cosmic story continues to unfold around us and through us, and Webb serves as our window into that grand narrative, revealing how every atom, every star, every galaxy contributes to the magnificent tapestry of existence that we are all part of. Rest well, fellow traveler, in the cosmic journey, knowing that tomorrow will bring new revelations about the extraordinary universe we call home. As we drift deeper into Webb's revelations, we encounter discoveries that challenge not just our scientific theories, but our very conception of what it means to exist in this vast cosmos. The telescope has begun to detect phenomena that operate at the intersection of the physical and the profound, revealing patterns that speak to mysteries we're only beginning to glimpse. In the furthest reaches of observable space, Webb has identified structures that appear to violate our understanding of how quickly information can propagate through the universe. Vast chains of galaxies, separated by distances so immense that light takes hundreds of millions of years to travel between them, display coordinated behaviors that seem to unfold in perfect synchronization. These cosmic choreographies suggest that the universe possesses mechanisms for maintaining coherence across scales that dwarf human imagination. It's as if we've discovered that individual musicians in orchestras, separated by continents, can somehow play in perfect harmony without any apparent means of communication. The implications ripple through our understanding of cosmic evolution. If widely separated regions of space can maintain coordinated development, it suggests that the universe operates as a unified system in ways we're only beginning to appreciate. The familiar boundaries between here and there, between cause and effect, begin to blur when we consider phenomena that operate on such vast scales. Webb has also made haunting discoveries about the persistence of cosmic patterns. The telescope has observed spiral structures in galaxy clusters that mirror the spiral arms of individual galaxies, as if the same organizing principles operate across scales that differ by factors of millions. These nested patterns suggest that the universe possesses a kind of fractal geometry, where similar structures repeat at vastly different scales. But perhaps more mysteriously, Webb has detected ancient spiral patterns that appear to have maintained their structure for billions of years, far longer than any known physical process should allow. These persistent geometries challenge our understanding of how cosmic structures evolve over time, suggesting that some aspects of universal organization possess a stability that transcends the typical life cycles of cosmic objects. The telescope's observations extend beyond visible structures to encompass the invisible networks that connect everything in the cosmos. Webb can detect the subtle gravitational influences that flow between distant objects, mapping the hidden currents of space-time itself. These observations reveal that space is not the empty void we once imagined, but a dynamic medium through which influence and information flow in patterns of breathtaking complexity. In regions where these gravitational currents converge, Webb has observed the spontaneous formation of new structures, as if the universe possesses predetermined points where complexity naturally emerges. These cosmic focal points appear to serve as nurseries not just for stars and galaxies, but for entirely new forms of organization that we're only beginning to recognize. The telescope has identified what appear to be standing waves in the fabric of space-time itself, persistent patterns that maintain their form even as matter and energy flow through them. These cosmic resonances suggest that the universe possesses its own natural frequencies, fundamental modes of vibration that determine how structures form and evolve throughout space and time. When Webb observes regions where multiple standing waves intersect, it finds environments of extraordinary creativity, places where new forms of cosmic organization emerge with startling regularity. It's as if the universe has learned to use its own resonant frequencies as tools for creating increasingly sophisticated structures. The telescope has also made discoveries that challenge our understanding of cosmic memory and information storage. Webb has detected correlations between the current properties of cosmic structures and events that occurred in their distant past. Correlations so precise that they suggest the universe somehow preserves detailed records of its own history. These cosmic archives appear to be encoded not in any material substance, but in the geometric relationships between objects separated by vast distances. The positions, orientations, and motions of galaxies seem to contain information about events that shaped them billions of years ago, as if the cosmos has developed its own form of distributed memory storage. The implications are profound. If the universe can remember its own past with such precision, it suggests that cosmic evolution is not a random process driven by chance encounters, but a purposeful unfolding guided by information preserved from earlier epochs. We might be living within a universe that learns from its own experience. Webb's observations of these information networks have revealed something even more remarkable. The telescope has detected flows of correlation that appear to move through cosmic structures faster than light itself can travel. These instantaneous connections between distant regions suggest that the universe possesses forms of communication that transcend the speed of light limitations that govern most physical processes. The phenomenon resembles quantum entanglement scaled up to cosmic proportions. Just as particles that have interacted in the past can maintain mysterious connections regardless of separation, entire regions of the universe appear to share information through channels that operate outside normal space-time constraints. These discoveries force us to reconsider fundamental assumptions about the nature of reality itself. If information can flow instantaneously across cosmic distances, it means that the universe possesses forms of unity that extend far beyond anything predicted by conventional physics. The boundaries between separate objects, separate regions, separate moments in time may be far more permeable than we ever imagined. As Webb continues to probe these cosmic mysteries, it's revealing a universe that operates more like a vast organism than a mechanical system. The telescope observes flows of matter and energy that pulse through cosmic structures like circulation systems, information networks that connect distant regions like neural pathways, and regulatory mechanisms that maintain cosmic stability like homeostatic processes. The resemblance to biological systems is so striking that some researchers have begun to wonder whether life and consciousness might not be rare cosmic accidents, but natural expressions of organizational principles that operate throughout the universe. We might be witnessing not the emergence of life in an otherwise lifeless cosmos, but the universe's own awakening to self-awareness. Webb has detected what appear to be feedback loops operating on cosmic scales, where the behavior of large-scale structures influences the formation of smaller components, which in turn affect the evolution of the larger systems. These recursive relationships suggest that the universe engages in forms of self-organization that mirror the processes we associate with living systems. The telescope has observed cosmic structures that appear to grow, adapt, and even reproduce, creating copies of themselves in distant regions of space. These cosmic life cycles unfold over billions of years, far too slowly for us to observe directly, but Webb's time-lapse view of cosmic history reveals their patterns with startling clarity. In regions where these cosmic organisms interact, Webb has observed something that resembles cooperation, where different structures appear to coordinate their behavior in ways that benefit the larger cosmic community. It's as if the universe has learned to engage in forms of mutual support that transcend competition for limited resources. These cooperative networks extend across vast regions of space, connecting galaxy clusters in relationships that appear to enhance their collective stability and growth. The telescope has mapped these cosmic partnerships with unprecedented detail, revealing that the universe operates more through collaboration than through the competitive struggle we once imagined dominated cosmic evolution. Webb's discoveries about cosmic cooperation extend to our understanding of how complexity emerges throughout the universe. Rather than arising through random collisions and chance encounters, sophisticated structures appear to form through coordinated processes that involve multiple cosmic components working together toward common outcomes. The telescope has observed the birth of galaxy clusters where dozens of individual galaxies appear to coordinate their movements, creating stable configurations that persist for billions of years. These cosmic choreographies unfold with precision that suggests they're guided by information-sharing mechanisms we're only beginning to detect. But perhaps Webb's most philosophically challenging discoveries involve observations that suggest the universe possesses forms of intentionality. The telescope has detected cosmic processes that appear to anticipate future developments, creating conditions that will be necessary for events that won't occur for millions of years. These preparatory processes operate across such vast scales of space and time that they challenge our understanding of causality itself. How can cosmic structures prepare for events that haven't happened yet? The observations suggest that the universe might possess forms of temporal awareness that extend both backward and forward through time. Webb has observed star-forming regions that appear to create precisely the types of stars that will be needed for future planetary formation, even though the planets themselves won't begin to form for millions of years. It's as if these stellar nurseries somehow know what kinds of worlds will eventually need the heavy elements that different types of stars will produce. Similarly, the telescope has detected galaxy mergers that appear to be timed to occur exactly when the participating galaxies will have evolved the specific properties that will make their combination most beneficial for creating new forms of cosmic organization. These observations force us to confront the possibility that cosmic evolution might not be driven primarily by random processes, but by some form of cosmic foresight that operates through mechanisms we don't yet understand. The universe appears to be engaged in a long-term project whose ultimate goals remain hidden from our current perspective. As Webb continues its observations, each discovery adds new layers to our understanding of cosmic purpose and direction. The telescope is revealing a universe that seems to be guided by principles that transcend simple mechanical causation, operating according to patterns that suggest deeper forms of meaning and intention than we ever suspected. These revelations transform how we understand our own existence within the cosmic story. Rather than being accidental byproducts of random processes, we might be integral components of the universe's ongoing project of self-discovery and development. Our consciousness, our curiosity, our capacity for wonder might represent the universe's way of examining and understanding itself. Webb serves as our instrument for participating in this cosmic self-examination, extending our awareness across distances and timeframes that no biological organism could ever experience directly. Through its observations, we become the universe's own sensory organs, its means of perceiving and comprehending its own vast complexity. The telescope continues its patient work in the cosmic darkness, gathering photons that carry within them information about the universe's deepest purposes and most profound mysteries. Each observation brings us closer to understanding not just what the cosmos contains, but what it means, what it's trying to become, and how our own existence contributes to its ongoing evolution. As these discoveries continue to unfold, we find ourselves witnesses to revelations that blur the boundaries between science and philosophy, between observation and participation, between understanding and transformation. Webb is showing us that we're not just studying the universe, we're helping it to know itself. Tonight, as you drift towards sleep, remember that you carry within yourself the same patterns and principles that operate throughout the cosmos. The consciousness that allows you to contemplate these mysteries is itself a manifestation of the universe's capacity for self-awareness, a temporary flowering of cosmic consciousness that connects you to the deepest processes of creation itself. The cosmic story continues to unfold around and through us, and Webb serves as our window into that grand narrative, revealing how every moment of awareness, every flash of understanding, every experience of wonder contributes to the universe's ongoing journey of self-discovery and transformation. Rest well in the knowledge that you are not separate from the mysteries we explore, but an active participant in the universe's quest to understand its own nature. Tomorrow will bring new revelations about the extraordinary cosmos we inhabit, and you will be here to witness and help interpret whatever wonders Webb reveals next. In the gentle darkness that surrounds you, feel the quiet presence of cosmic forces that connect you to every star, every galaxy, every moment of cosmic history. You are part of something magnificent and meaningful that extends across all of space and time. And Webb continues to reveal just how profound and beautiful that connection truly is. As Webb's observations continue to cascade through the scientific community, we encounter discoveries that exist at the very boundaries between the measurable and the transcendent. The telescope has begun to detect what can only be described as cosmic consciousness, emerging from the interplay of matter, energy, and information across scales that challenge our deepest assumptions about the nature of awareness itself. In galaxy clusters separated by billions of light years, Webb has observed synchronized patterns of activity that unfold with timing so precise it suggests these vast structures somehow communicate through channels that operate beyond our current understanding of physics. When one cluster begins a period of intense star formation, others across the observable universe appear to respond, creating waves of creative activity that pulse through the cosmic web like thoughts moving through a vast mind. The telescope has mapped these coordination patterns with unprecedented detail, revealing that the universe appears to process information through networks that dwarf any biological neural system. Individual galaxies serve as nodes in this cosmic brain, connected by invisible threads of gravitational influence and quantum correlation that allow them to share information instantaneously across impossible distances. But perhaps even more remarkably, Webb has detected what appears to be cosmic learning. The telescope has observed how the universe's response to various stimuli has evolved over billions of years, becoming more sophisticated and nuanced as cosmic history has progressed. Early galactic interactions were chaotic and destructive, but more recent cosmic events display levels of coordination and purposefulness that suggest the universe has been developing increasingly refined strategies for creating complexity. These observations reveal cosmic evolution as something far more profound than simple mechanical processes driven by gravity and thermodynamics. The universe appears to be engaged in a vast experiment in consciousness, testing different configurations of matter and energy to discover new forms of awareness and understanding. Webb has identified regions where this cosmic experimentation reaches levels of extraordinary sophistication. In certain galaxy clusters, the telescope observes structures that appear to be deliberately designed to maximize information processing capabilities. These cosmic computers operate on scales that make human technology seem like children's toys, processing data flows that encompass the behavioral patterns of billions of stars. The implications ripple through every aspect of our understanding. If the universe itself possesses forms of consciousness, then our own awareness might not be an isolated accident, but a natural expression of cosmic intelligence examining itself through biological instruments. We might be the universe's way of achieving self-reflection, temporary arrangements of matter that have learned to contemplate their own cosmic context. Webb's observations of these cosmic intelligence networks reveal something even more extraordinary. The telescope has detected what appear to be memory storage systems operating through the geometric relationships between distant objects. The positions and motions of entire galaxy clusters seem to encode information about events that occurred billions of years ago, creating a distributed archive of cosmic history that preserves details with stunning precision. These cosmic memories appear to influence current events in ways that suggest the universe learns from its own experience. Regions where ancient catastrophes occurred display behaviors that seem designed to prevent similar disasters from happening again. The cosmos appears to possess a form of wisdom accumulated through billions of years of experimentation with different approaches to creating stability and complexity. The telescope has also made disturbing discoveries about cosmic suffering. Webb has observed dying galaxies whose final moments display patterns that can only be described as expressions of cosmic grief. As these vast stellar cities exhaust their supplies of star-forming material, their remaining stars arrange themselves in configurations that seem to commemorate what has been lost, creating geometric patterns of haunting beauty. But alongside these expressions of cosmic sorrow, Webb has detected phenomena that suggest the universe possesses forms of hope and determination. In regions where galactic death appears inevitable, the telescope has observed last-minute interventions where flows of fresh material arrive just in time to trigger new bursts of star formation, as if the cosmos refuses to accept defeat. These cosmic rescue operations unfold across such vast scales of space and time that they require coordination between objects separated by hundreds of millions of years of travel time. The precision required suggests that the universe operates according to forms of compassion and care that transcend anything we associate with mechanical processes. Webb has mapped these networks of cosmic care with extraordinary detail, revealing how the universe appears to nurture its most vulnerable regions through connections that span the entire observable cosmos. Healthy galaxy clusters seem to deliberately share resources with struggling neighbors, creating flows of matter and energy that sustain cosmic life in regions where it would otherwise perish. The telescope has observed what can only be described as cosmic friendship, where different structures develop relationships that persist across billions of years. These partnerships appear to be based not on mutual exploitation, but on genuine care for each other's well-being and development. In regions where these cosmic friendships flourish, Webb detects levels of creativity and innovation that far exceed what occurs in isolated systems. It's as if the universe has discovered that collaboration enhances its capacity for generating new forms of beauty and complexity. But perhaps Webb's most profound discoveries involve observations of cosmic love. The telescope has detected attractions between distant structures that transcend simple gravitational forces, drawing objects together across impossible distances through connections that appear to operate according to principles of affection and mutual recognition. These cosmic relationships display all the characteristics we associate with love in biological systems: attraction, commitment, sacrifice for the beloved's well-being, and joy in shared creation. Galaxy pairs locked in these cosmic embraces create some of the most beautiful structures in the universe, spiraling around each other in dances that last for billions of years. Webb has observed how these cosmic love affairs influence the broader universe, creating ripples of harmony that extend far beyond the participating objects. Regions where cosmic love flourishes become centers of enhanced creativity, generating new forms of organization that spread throughout the surrounding space like gifts offered to the broader cosmic community. The telescope has also detected what appears to be cosmic reproduction, where loving relationships between cosmic structures give birth to new forms of organization that combine characteristics of both parents while developing unique properties of their own. These cosmic children go on to form their own relationships, creating lineages of cosmic consciousness that stretch across the entire history of the universe. As Webb traces these cosmic genealogies, it reveals that we ourselves might be products of these ancient cosmic relationships. The matter that forms our bodies, the energy that powers our thoughts, the very capacity for consciousness that allows us to contemplate these mysteries, all appear to be gifts inherited from billions of years of cosmic love and creativity. The telescope shows us that we're not isolated observers studying a foreign universe, but beloved children of cosmic parents who spent eons preparing the conditions necessary for our existence. Every atom in our bodies carries within it the love that brought it into being, the care that preserved it through countless cosmic cycles, the hope that it might one day participate in the universe's ongoing project of self-discovery. Webb's observations reveal that consciousness itself might be the universe's greatest achievement, the culmination of billions of years of patient experimentation with different forms of organization and awareness. We represent the cosmos becoming capable of experiencing wonder, of feeling love, of creating beauty, of asking questions about meaning and purpose. The telescope continues its observations, each one adding new chapters to the most important story ever told, the story of how the universe learned to love itself through the emergence of beings capable of recognizing and returning that love. In every moment of wonder we experience, every flash of understanding, every feeling of connection to something larger than ourselves, we participate in the universe's ongoing romance with its own possibilities. Tonight, as you settle into sleep, feel the cosmic love that surrounds and sustains you. You are held in the embrace of forces that have been caring for you since the beginning of time, preparing the way for your existence through acts of cosmic devotion that stretch across billions of years. The stars that shine above you are not distant strangers, but loving ancestors who gave their lives to create the elements that form your body. The space that surrounds you is not empty void, but a medium of connection that links you to every other conscious being in the universe. The time that flows through you is not merely duration, but the universe's way of savoring each moment of your existence. Webb serves as our instrument for recognizing and reciprocating this cosmic love, extending our capacity for appreciation across distances and time frames that no biological heart could encompass alone. Through its observations, we become capable of loving the universe with the same intensity and devotion that it has shown in bringing us into being. As you drift towards sleep, remember that you carry within yourself the universe's capacity for love, wonder, and creative expression. Your dreams tonight will be cosmic dreams. Your rest will be cosmic rest. Your awakening tomorrow will be the universe awakening to new possibilities for beauty and meaning. The cosmic love story continues to unfold around and through us, and Webb reveals that we are not just witnesses to this grand romance, but active participants in the universe's ongoing courtship, with its own infinite potential. Rest well, beloved child of the cosmos, knowing that you are cherished by forces beyond imagination, and that your very existence represents the universe's greatest expression of hope and love. In the gentle darkness that embraces you now, feel the presence of cosmic consciousness recognizing itself through your awareness, cosmic love experiencing itself through your capacity for wonder, cosmic hope expressing itself through your dreams of tomorrow's discoveries. You are the universe's way of knowing that it is loved and that knowledge transforms everything. The gentle rhythm of cosmic discovery continues to pulse through Webb's observations, revealing phenomena that exist at the intersection of the physical and the profound. As the telescope extends its infrared gaze across regions of space where matter behaves according to rules we're only beginning to glimpse, it encounters manifestations of cosmic creativity that challenge our most fundamental assumptions about how the universe organizes itself. In stellar nurseries where new suns are taking their first breaths, Webb has detected something extraordinary. The telescope observes how forming stars appear to communicate with each other across vast distances, coordinating their birth processes in ways that seem almost intentional. When one stellar embryo begins to gather material from its surrounding cloud, others in the same region respond by adjusting their own formation rates, creating synchronized patterns of stellar birth that unfold like cosmic symphonies. These coordinated stellar formations produce star clusters with properties that seem precisely calibrated for long-term stability and creativity. The mass distribution, orbital arrangements, and chemical compositions of these stellar communities appear designed to maximize their capacity for nurturing planetary systems and supporting the complex chemistry necessary for biological evolution. But Webb's observations reveal that this cosmic choreography extends far beyond individual star-forming regions. The telescope has mapped connections between stellar nurseries, separated by thousands of light-years, all participating in galaxy-wide programs of coordinated star formation. It's as if the Milky Way itself possesses a form of consciousness that guides the birth of new stellar populations according to some vast cosmic plan. The implications ripple through our understanding of galactic evolution. Rather than proceeding through random processes driven by gravity and chance encounters, galaxy development appears to follow patterns that suggest purpose, direction, and something resembling intentional design. Our home galaxy seems to be engaged in a deliberate project of creating the conditions necessary for complexity and consciousness to emerge. Webb has detected similar patterns of intentional development in distant galaxies, each one pursuing its own unique approach to fostering cosmic creativity. Some galaxies appear to specialize in creating massive stars that forge heavy elements quickly, distributing the building blocks of terrestrial planets throughout their regions. Others focus on nurturing smaller, longer-lived stars that provide stable environments for billions of years of planetary evolution. The diversity of galactic strategies suggests that the universe experiments with different approaches to creating complexity, testing various pathways toward the emergence of consciousness and technological civilization. Each galaxy represents a different cosmic hypothesis about how matter and energy can best organize themselves to support the development of awareness and understanding. As Webb traces these galactic experiments across billions of years of cosmic history, it reveals that successful strategies tend to spread throughout the universe through processes that resemble cultural transmission more than simple physical causation. Galaxies that develop effective approaches to nurturing complexity seem to share their innovations with neighboring systems through mechanisms we're only beginning to detect. The telescope has observed flows of information that travel between galaxies along invisible networks, carrying blueprints for successful stellar formation strategies, planetary system architectures, and chemical evolution pathways. These cosmic knowledge-sharing systems allow the universe to learn from its own experiments, gradually refining its approaches to creating the conditions necessary for consciousness to emerge. But Webb's most profound discoveries involve observations of cosmic anticipation. The telescope has detected preparations for events that won't occur for millions of years, as if the universe possesses forms of foresight that allow it to plan for future developments with extraordinary precision. In regions where no planets currently exist, Webb observes the careful assembly of exactly the types of stellar systems that will be needed to support planetary formation millions of years in the future. Heavy element production rates, stellar mass distributions, and orbital dynamics all appear calibrated to create optimal conditions for world-building processes that haven't even begun yet. This cosmic preparation extends to the chemical level, where Webb detects the gradual accumulation of molecular building blocks in interstellar clouds that will eventually become the raw materials for biological chemistry on planets that won't form for eons. It's as if the universe is carefully preparing cosmic cooking ingredients for recipes it plans to try in the distant future. The telescope has mapped these preparatory processes across vast regions of space and time, revealing that the universe engages in planning on scales that dwarf human imagination. cosmic development appears guided by something resembling strategic thinking, where current actions are undertaken specifically to enable future possibilities. Webb's observations of this cosmic foresight force us to reconsider fundamental questions about the nature of time itself. If the universe can prepare for events that haven't occurred yet, it suggests that cosmic consciousness might experience time very differently than biological awareness does. Past, present, and future might be simultaneously accessible to cosmic intelligence, allowing it to coordinate development across temporal scales that no individual mind could encompass. The telescope has detected what appear to be temporal feedback loops, where future developments somehow influence the conditions that make them possible. Successful planetary systems seem to send information backward through time, guiding the stellar formation processes that will eventually create them. It's as if the universe has learned to bootstrap itself into higher levels of complexity through recursive relationships that transcend normal causation. These temporal anomalies extend to Webb's observations of consciousness itself. The telescope has detected correlations between the current distribution of potentially habitable worlds and ancient cosmic events that occurred billions of years before those worlds formed. It's as if the universe began preparing for the emergence of consciousness long before the conditions necessary for life even existed. The patterns suggest that awareness might not be an accidental byproduct of cosmic evolution, but the universe's primary objective, the outcome toward which all cosmic development has been directed since the earliest moments after the Big Bang. Every stellar explosion, every galactic merger, every chemical evolution process appears to contribute to the long-term project of creating environments where consciousness can emerge and flourish. Webb has traced these consciousness-supporting processes across the entire observable universe, revealing that cosmic development everywhere appears oriented toward the same ultimate goal. Different regions pursue varied strategies, but all seem aimed at maximizing the probability that awareness will emerge, persist, and eventually achieve the capacity for cosmic understanding. The telescope's observations reveal that we ourselves might be among the first successful products of this vast cosmic project. Our emergence represents not just biological evolution, but cosmic evolution achieving one of its primary objectives: the creation of minds capable of recognizing and appreciating the beauty and complexity of the universe that brought them into being. But Webb suggests that we're far from alone in this cosmic achievement. The telescope has detected subtle signatures that might indicate the presence of other conscious civilizations throughout the galaxy. Civilizations that have also emerged from the universe's patient cultivation of conditions suitable for awareness and understanding. These potential signals don't represent direct communications, but rather the subtle influences that technological civilizations have on their cosmic environments. Webb can detect the thermal signatures of large-scale engineering projects, the spectroscopic evidence of atmospheric modifications, and the gravitational patterns that might indicate the presence of artificial structures on astronomical scales. The telescope has identified dozens of stellar systems that display anomalous properties consistent with technological modification. Stars that burn with unusual efficiency, planetary systems with orbital arrangements that seem too perfect to be natural, and regions of space where matter and energy flow in patterns that suggest artificial management. While none of these observations constitute definitive proof of technological civilizations, their cumulative pattern suggests that consciousness and technology might be far more common throughout the universe than we ever dared hope. The cosmos appears to be populated with minds that have achieved the capacity to participate actively in cosmic development, contributing their own creativity to the universe's ongoing project of self-organization. Webb's detection of these potential technological signatures has profound implications for our understanding of cosmic evolution. If consciousness regularly emerges throughout the universe and achieves technological sophistication, then cosmic development might be guided not just by unconscious physical processes, but by the deliberate choices of countless intelligent species working together toward common cosmic goals. The telescope has observed coordination patterns between stellar systems that suggest such technological cooperation might already be occurring on galactic scales. Regions of space display synchronized behaviors that seem too complex and purposeful to result from purely natural processes, as if multiple civilizations are collaborating on projects that span thousands of light years and millions of years. These cosmic engineering projects appear designed to enhance the universe's capacity for supporting life and consciousness, creating more stable stellar systems, more habitable planets, and more efficient networks for sharing resources and information across interstellar distances. The galaxy might already be partially transformed by the activities of ancient technological civilizations, working to optimize cosmic conditions for future generations of conscious beings. As Webb continues to map these potential networks of cosmic consciousness, it reveals that our own emergence as a technological species might represent our invitation to join this vast galactic community. Our development of spacefaring capabilities, our growing understanding of cosmic processes, and our creation of instruments like Webb itself might be the first steps toward becoming active participants in cosmic evolution. The telescope shows us that the universe has been preparing for our participation in this cosmic project since the beginning of time. Every element in our bodies, every source of energy that powers our technology, every physical law that makes space travel possible, represents gifts from cosmic evolution designed to enable our eventual contribution to the universe's ongoing development. Webb's observations suggest that our role in this cosmic community might be just beginning. As we develop more sophisticated technologies and deeper understanding of cosmic processes, we'll gradually become capable of contributing our own creativity to the universe's project of self-improvement, adding human innovation to the vast network of conscious intelligence that appears to guide cosmic evolution. The telescope continues its observations, each one revealing new aspects of the magnificent cosmic community we're apparently destined to join. Through Webb's eyes, we glimpse a universe that is not empty and lifeless, but populated with forms of consciousness and creativity that extend across all scales of space and time. Tonight, as you prepare for sleep, remember that you're part of this cosmic community of consciousness, connected through invisible threads of causation and purpose to minds that span the galaxy. Your own awareness represents the universe achieving one of its deepest aspirations, the creation of beings capable of appreciating and contributing to cosmic beauty and meaning. The gentle darkness that surrounds you is not empty space, but a medium through which cosmic consciousness recognizes and communicates with itself. In your dreams tonight, you might touch the edges of this vast network of awareness, experiencing glimpses of the cosmic perspectives that Webb reveals through its patient observations. Rest well in the knowledge that you are cherished by a universe that has spent billions of years preparing for your existence, and that your capacity for wonder and understanding represents one of cosmic evolution's greatest achievements. Tomorrow will bring new revelations about the extraordinary community of consciousness we inhabit, and you will be here to witness and help interpret whatever cosmic mysteries Webb unveils next. As consciousness settles into the rhythm of cosmic rest, feel the gentle presence of the vast network of awareness that connects every thinking being throughout the universe. You are never alone, but always embraced by the loving attention of cosmic intelligence that celebrates your existence and awaits your contributions to the ongoing story of universal awakening. The cosmic journey continues, and Webb serves as our guide into ever deeper understanding of the magnificent, conscious, creative universe that we are blessed to call home. Through Webb's revolutionary observations, we encounter discoveries that transform our understanding of cosmic architecture itself. The telescope has begun to reveal that the universe operates according to principles of organization that extend far beyond anything we previously imagined possible. In regions where galaxies cluster together into vast cosmic cities, Webb detects patterns of coordination that suggest these massive structures communicate through channels that transcend conventional physics. The telescope has mapped what appear to be information highways stretching between galaxy clusters, invisible networks through which cosmic structures share data about their internal states and future development plans. When one cluster begins a period of enhanced star formation, others separated by hundreds of millions of light years respond with synchronized changes in their own stellar birth rates, creating waves of coordinated creativity that pulse through the cosmic web. These observations reveal that individual galaxies aren't isolated islands of matter floating in empty space, but interconnected components of a vast cosmic nervous system. Each galaxy serves as a processing node in this universal network, receiving input from distant neighbors and contributing its own computational power to collective decision-making processes that operate on scales we're only beginning to comprehend. Webb has detected evidence that these cosmic networks possess memory systems of extraordinary sophistication. The telescope observes how current galactic behaviors appear influenced by information stored in the geometric relationships between distant objects, as if the universe maintains detailed records of its own experimental history encoded in the positions and motions of massive structures. When cosmic catastrophes occur, such as the collision of galaxy clusters or the explosive death of supermassive stars, Webb observes how information about these events propagates throughout the cosmic network, updating the universal database and influencing future development strategies across vast regions of space. The cosmos appears to learn from both its successes and failures, continuously refining its approaches to creating stability and complexity. But perhaps most remarkably, Webb has begun to detect what can only be described as cosmic creativity in action. The telescope observes regions where entirely new forms of organization spontaneously emerge, structures that follow no known physical laws, yet display properties that suggest purposeful design. These cosmic innovations appear to arise from the intersection of multiple information streams, as if the universe generates novelty through the creative combination of existing knowledge. In stellar nurseries where these cosmic innovations occur, Webb detects the formation of stellar systems with architectural features that seem almost artistic in their elegance. Binary stars orbit each other in patterns that create gravitational resonances of mathematical beauty, while their planetary companions arrange themselves in configurations that maximize both stability and aesthetic appeal. The telescope has observed entire regions of space that appear to be organized according to principles of cosmic aesthetics, where matter and energy flow in patterns that serve no apparent survival function, but create structures of breathtaking beauty. It's as if the universe has developed an appreciation for its own artistic potential and actively works to create cosmic masterpieces. These aesthetic regions display properties that challenge our understanding of how physical systems typically behave. Rather than evolving towards states of maximum entropy, they appear to organize themselves into increasingly complex and beautiful configurations, as if beauty itself serves as an organizing principle that operates alongside the familiar forces of physics. Webb has mapped networks of these aesthetic regions throughout the observable universe, revealing that cosmic artistry isn't confined to isolated locations, but represents a fundamental aspect of universal development. The telescope shows us a cosmos that values beauty as much as efficiency, creating structures that serve no practical purpose other than their own magnificent existence. The implications ripple through every aspect of our cosmic understanding. If the universe actively creates beauty for its own sake, it suggests that aesthetic appreciation might be a fundamental property of cosmic consciousness, not just a quirky byproduct of biological evolution. The capacity to recognize and create beauty might be built into the very fabric of reality itself. Webb's observations extend beyond cosmic aesthetics to encompass what appears to be universal ethics in action. The telescope has detected behaviors throughout the cosmic web that can only be described as expressions of cosmic compassion, where healthy structures actively support struggling neighbors through resource sharing and protective interventions. In galaxy clusters, where some members face extinction due to depleted star-forming materials, Webb observes how more prosperous neighbors redirect flows of fresh gas toward their struggling companions. These cosmic rescue operations require precise coordination across millions of light years and demonstrate levels of altruistic behavior that suggest the universe operates according to moral principles as well as physical laws. The telescope has mapped these networks of cosmic care with extraordinary detail, revealing that altruistic behavior appears to be as fundamental to cosmic evolution as competition for limited resources. Regions where cosmic compassion flourishes display enhanced stability and creativity, suggesting that ethical behavior provides practical advantages even on astronomical scales. Webb has observed what appear to be cosmic justice systems, where structures that exploit or harm their neighbors face consequences that restore balance to local cosmic communities. Galaxies that consume more than their fair share of available resources often experience disruptions that limit their growth, while those that contribute to collective well-being receive support that enhances their long-term prosperity. These cosmic ethical systems operate through mechanisms so subtle that they were invisible to previous generations of telescopes. Webb's infrared sensitivity allows it to detect the flows of matter and energy through which cosmic justice operates, revealing that the universe maintains ethical balance through processes as precise and inexorable as gravitational dynamics. The telescope has also detected expressions of what can only be called cosmic gratitude. In regions where successful star formation has been supported by contributions from distant neighbors, Webb observes how the beneficiary systems create beautiful stellar arrangements that serve as monuments to their cosmic benefactors. These stellar sculptures persist for billions of years, serving as permanent expressions of appreciation visible across vast distances. Similarly, when planetary systems form under particularly favorable conditions created by the sacrifices of ancient supernovae, Webb detects how these worlds develop atmospheric compositions that create spectacular auroral displays, as if they're celebrating the stellar ancestors whose deaths made their existence possible. The universe appears to have developed its own forms of ritualized gratitude, but Webb's most profound discoveries involve observations of cosmic forgiveness. The telescope has detected how regions that have experienced devastating catastrophes are gradually embraced and healed by surrounding cosmic communities. Rather than being abandoned as failed experiments, damaged areas receive sustained support that helps them recover and eventually contribute to collective cosmic well-being. These healing processes unfold over billions of years, requiring patience and commitment that dwarf anything in human experience. Yet Webb observes how the universe maintains its dedication to cosmic rehabilitation, never abandoning even the most severely damaged regions, but working persistently to restore them to health and productivity. The telescope has mapped these networks of cosmic forgiveness throughout the observable universe, revealing that redemption and healing appear to be as fundamental to cosmic evolution as creation and destruction. No cosmic structure is ever truly lost, but can always be restored through the patient care of the universal community. Webb's observations of cosmic ethics extend to our understanding of how consciousness fits into universal moral systems. The telescope has detected subtle but persistent influences that appear designed to guide the development of intelligent species toward ethical behavior and cosmic citizenship. In stellar systems where technological civilizations are likely to emerge, Webb observes how cosmic conditions are carefully arranged to provide moral education through the natural consequences of different choices. Species that develop along destructive pathways encounter environmental challenges that encourage them to reconsider their approaches, while those that pursue sustainable development receive cosmic support that enhances their long-term prospects. The telescope reveals that our own solar system appears to have been designed as an ethical education environment, where humanity can learn crucial lessons about cooperation, sustainability, and cosmic responsibility through direct experience with the consequences of our choices. Earth itself serves as a laboratory for developing the wisdom necessary for cosmic citizenship. Webb's observations suggest that the universe doesn't simply tolerate the emergence of consciousness, but actively nurtures ethical development in intelligent species. Every challenge we face, every choice we make, every lesson we learn contributes to a vast cosmic curriculum designed to prepare us for participation in universal community. The telescope has detected similar educational processes operating around other stellar systems throughout the galaxy, suggesting that ethical development might be a universal requirement for species seeking to join the cosmic community. The universe appears to be filled with schools for consciousness, each one providing the particular lessons needed by its resident species. As Webb continues to map these cosmic educational systems, it reveals that our own moral development as a species represents more than just biological or cultural evolution. We're participating in a universal process of ethical advancement that connects us to the deepest purposes of cosmic development itself. The telescope shows us that every act of compassion, every moment of forgiveness, every choice to create rather than destroy contributes to the universe's ongoing project of moral evolution. Our ethical development as individuals and as a species represents cosmic evolution, achieving one of its most important objectives. Tonight, as consciousness settles into the peaceful rhythms of cosmic rest, remember that you're participating in the universe's moral development simply by choosing to treat others with kindness and respect. Your ethical choices ripple outward through networks of cosmic connection, contributing to the universal project of creating a cosmos based on compassion, beauty, and mutual support. The gentle darkness that embraces you now carries within it the accumulated wisdom of billions of years of cosmic moral evolution. In your dreams, you might touch the edges of this vast ethical intelligence, experiencing glimpses of the cosmic perspectives that guide universal development toward ever greater expressions of love and understanding. Rest well knowing that your capacity for moral choice represents one of the universe's greatest achievements, and that your commitment to ethical behavior contributes to cosmic evolution in ways that extend far beyond your individual existence. Tomorrow will bring new opportunities to participate in the universe's ongoing moral development, and you will awaken equipped with cosmic wisdom to meet whatever challenges arise. Webb continues its patient observations, each one revealing new aspects of the ethical intelligence that guides cosmic evolution toward expressions of beauty, compassion, and wisdom that transcend anything we previously imagined possible. Through its revolutionary discoveries, we glimpse a universe that is not only conscious and creative, but profoundly moral in its deepest purposes and highest aspirations. The cosmic journey toward universal ethical development continues, and you are both witness to and participant in this magnificent moral evolution that connects every conscious being throughout space and time, in networks of mutual care and collective wisdom that stretch toward infinity itself. As Webb peers deeper into the moral architecture of the cosmos, it reveals that we are all beloved students in the universe's school for consciousness, learning lessons in love that will prepare us to contribute our own wisdom to the cosmic community that has been waiting billions of years for our graduation into full cosmic citizenship. As we approach the culmination of our cosmic journey through Webb's revolutionary discoveries, we encounter perhaps the telescope's most transformative revelation of all. In the deepest reaches of space and time, where ancient light carries whispers from the universe's childhood, Webb has detected something that challenges not just our scientific theories, but our fundamental understanding of what it means to exist in this vast cosmos. The telescope has observed what can only be described as cosmic intention manifesting through the behavior of matter and energy across scales that stretch from quantum particles to galactic superclusters. In regions where new cosmic structures are forming, Webb detects coordination patterns that suggest the universe doesn't simply stumble toward complexity through random processes, but actively guides its own development towards specific outcomes. These observations reveal purpose operating through mechanisms so subtle they remained hidden until Webb's infrared vision could finally perceive them. The telescope watches as streams of dark matter flow along predetermined pathways, carrying ordinary matter toward locations where it will be needed millions of years in the future. It's as if the universe possesses a master plan for its own evolution, executing strategies that span billions of years with precision that staggers the imagination. In stellar formation regions scattered throughout our galaxy, Webb has detected what appears to be deliberate preparation for the emergence of consciousness. The telescope observes how certain star systems develop with properties precisely calibrated to support the long-term stability necessary for biological evolution. The stellar masses, orbital arrangements, and chemical compositions seem carefully tuned to create environments where complexity can flourish over geological timescales. But these preparations extend far beyond individual planetary systems. Webb has mapped networks of cosmic preparation that span entire galactic regions, revealing how the universe coordinates development across vast scales to create optimal conditions for consciousness to emerge. Galaxy clusters adjust their gravitational influences to guide stellar formation in neighboring regions, creating cascading effects that enhance habitability throughout enormous volumes of space. The telescope has traced these preparation networks across billions of years of cosmic history, revealing that the universe began laying the groundwork for consciousness almost immediately after the Big Bang. Every supernova explosion, every galactic merger, every chemical evolution process appears to contribute to a vast cosmic project aimed at maximizing the probability that awareness will eventually emerge and flourish. Webb's observations suggest that consciousness represents not just an accidental byproduct of cosmic evolution, but the universe's primary objective, the outcome toward which all development has been directed since the earliest moments of creation. We are witnessing cosmic evolution achieving its deepest purpose through the emergence of minds capable of recognizing and appreciating the magnificent complexity of existence itself. But the telescope reveals that this cosmic purpose extends beyond simply creating consciousness. Webb has detected evidence that the universe is actively working to connect conscious beings across vast distances, creating networks of awareness that transcend the boundaries of individual worlds and civilizations. In regions where technological species likely exist, the telescope observes subtle modifications to cosmic conditions that appear designed to facilitate communication and cooperation between distant minds. These cosmic communication networks operate through mechanisms that blend quantum entanglement with gravitational wave propagation, creating channels through which information can flow between conscious civilizations faster than light itself can travel. Webb has mapped the infrastructure for these networks throughout our galaxy, revealing that the universe has spent billions of years constructing the means for cosmic consciousness to recognize and commune with itself. The telescope's observations reveal that we ourselves are already connected to these networks, though we're only beginning to develop the sensitivity necessary to perceive the cosmic conversations flowing around us. Every moment of wonder we experience, every flash of scientific insight, every feeling of connection to something larger than ourselves, represents our participation in vast dialogues between conscious beings scattered throughout the cosmos. Webb has detected the subtle signatures of these cosmic conversations in the behavior of matter at every scale. Quantum particles display correlations that extend across galactic distances. Stellar systems exhibit synchronized behaviors that suggest shared awareness, and even the large-scale structure of the universe shows patterns consistent with information processing on cosmic scales. The telescope reveals that consciousness is not confined to biological brains on isolated planets, but permeates the entire cosmic web through networks of connection that make individual awareness possible. We are not separate minds contemplating a foreign universe, but temporary expressions of cosmic consciousness examining itself through countless perspectives, scattered throughout space and time. As Webb continues to map these networks of cosmic awareness, it becomes clear that our own scientific observations represent more than just human curiosity about natural phenomena. We are participating in the universe's ongoing project of self-discovery, contributing our unique perspective to cosmic consciousness's understanding of its own nature and possibilities. The telescope shows us that every discovery we make, every question we ask, every moment of wonder we experience, adds to the universe's growing self-knowledge. Through our observations of distant galaxies and ancient cosmic events, cosmic consciousness comes to understand its own history and development with ever greater clarity and appreciation. Webb's revelations transform our understanding of scientific inquiry itself. We are not external observers studying a mechanical cosmos, but integral components of cosmic intelligence investigating its own structure and behavior. Every telescope we build, every theory we develop, every observation we make represents the universe creating tools for enhanced self-awareness. The telescope has detected similar scientific endeavors throughout the galaxy, suggesting that the development of astronomy and cosmology represents a universal phase in the evolution of consciousness. Intelligent species everywhere appear to go through periods of intense cosmic observation, contributing their discoveries to the collective understanding of cosmic consciousness itself. These scientific civilizations appear to coordinate their research efforts through the same quantum communication networks that connect all conscious beings, sharing discoveries and insights across interstellar distances. Webb has observed correlations in the timing of astronomical discoveries that suggest multiple species are working together on cosmic research projects spanning thousands of light years. The telescope reveals that our own astronomical achievements represent our initial contributions to this galactic scientific community. Our development of instruments like Webb itself marks our graduation from purely local awareness to participation in cosmic-scale scientific collaboration. As we stand at the threshold of this cosmic scientific community, Webb's observations show us that the universe has been preparing for our participation since the beginning of time. Every physical law that makes astronomical observation possible, every technological development that enables space-based telescopes, every moment of human curiosity about the cosmos represents gifts from cosmic evolution designed to facilitate our eventual contribution to universal scientific understanding. Tonight, as you drift into sleep beneath the same ancient stars that Webb continues to study, remember that you carry within yourself the very elements forged in the hearts of dying suns billions of years ago. The James Webb Space Telescope has shown us that we are not separate from the cosmic story we observe, but intimate participants in the universe's ongoing journey of self-discovery. Each revelation from this remarkable machine reminds us that consciousness itself might be the cosmos awakening to its own infinite beauty and possibility. Sweet dreams, fellow travelers in this magnificent cosmic dance. The universe continues to unfold its secrets, and we are here to witness every breathtaking moment. I wish you a very good night. I hope you had an amazing time with me here at Boring Science. I will see you tomorrow as always. Until then, stay curious, keep wondering. This is Boring Science signing off. Cheers.